Recently here on Wi-Fi Sheep, we looked at the Motoduino Lab Node MCU ESP32S development board kit, a rather brilliant ESP32 based product supplied by techdesign.com IoT marketplace. Well, guess what? We have a second product to play with. This is the blood oxygen and temperature monitor learning kit, also from Taiwanese based manufacturer Motoduino Lab. Now, Motoduino Lab is one of the many tech-based suppliers on the rather brilliant techdesign.com IoT marketplace. TechDesign's unique IoT marketplace allows a direct source and link between manufacturers and people like us in the hobby tech community, bringing together over 500 plus verified electronic design and manufacturing suppliers to support you throughout your product development journey. You can also jumpstart your project by leveraging one of TechDesign's 1600 plus customizable electronic hardware and IoT solutions, not only to reduce costs but also reduce time during your hardware development. So whether you're sourcing a small quantity of components for testing or a larger purchase for mass production, all orders are processed and shipped directly by manufacturers listed on techdesign.com. So here we are then. This is the blood oxygen and temperature monitor learning kit by Motoduino Lab and brought to us courtesy of techdesign.com IoT marketplace. If I just show you the website here, this is the page for it on techdesign.com. Links, by the way, are in the description to this video. And as we can see, it's a kit for it reads data by sensors and prints out results through OLED module. Blood oxygen and body temperature data can be shown simultaneously on screen, and it shows you what it contains. It's very similar to the previous product, but it does contain a couple of additional sensors and features. And then we see down here, this is what the kit contains. And we've got some pictures here. So without further ado, let's have a look at opening the box. Again, it comes in this really nice, sturdy plastic case. And I said before, I really like these cases. It shows it's a product worth protecting and there's some value. This again comes with a ESP32. We've got a fair few sensors and things to have a look at in a minute. Another USB to micro USB cable. Identical to the previous product, here is another soldered and ready to go iMoto ESP32 IO development board. By the way, if you've not already seen the previous video, do go and check that out because I go into more detail about what I thought about these boards. But basically, I think these are absolutely fantastic. They're very feature rich, very well put together. And the fact they are actually put together and not a bag of bits that you have to solder yourself is extremely useful. So this on its own is a fantastic launchpad platform for other IoT or dev board type creations. We then have a series of female to female jumpers, and we have, now this is a little bit different, so it's 4 jumpers, female jumpers on one side, and on the other side it is what looks like a telephone or Ethernet jack. It isn't, it's the RJ11 style plug. And basically with the iMoto boards from Motoduino Lab, they break out a series of key functions from the ESP32, again using these RJ11 type sockets. We've got digital, analog, UART, and we've got I2C there on the end, and you can simply plug in as you would a phone or Ethernet connection. It's a really neat way of doing it, it's so clean. And then we've actually got the pin connectors for breakout into the various sensors that are actually going to be present in today's product. So let's take a look at the sensors, shall we? So this is the first one, which is in a little Ziploc type bag. Let's try and get that open. There we go. It's a piece of protective foam. And you can see this is the temperature sensor. It's a little different to the last temperature sensor. This is for actually taking body temperature, so I believe it does require at least a very close, or if not a contact with skin, to take a temperature. But you can see here it is labelled as voltage, ground, SCL and SDA. The second one here, which is a slightly different package bag, this is a strip bag. which we may need some scissors to assist here. There we are. Right, we're in. Now this is the blood level oxygen sensor. You can see there it's actually got it on the silk screen on the underside, so it's clearly marked what it is. The pins again, the same pretty much as before. VIN, SDA, SCL and ground, but in a slightly different configuration. And you can see there is the actual sensor itself neatly on the centre of the board, and you've also got further breakout pins on this side. So this actually has the ability for future flexibility once we've got it up and running in this basic kit form. We'll take a look at this one next, which I think if you've seen the previous video, you'll know what this is. So this is another one of the tiny little OLED displays, which worked really well last time, which again has the kind of protective covering on, so we can take that off. Got that there. The ESP32 itself, I think it's fantastic that the kit actually comes with these boards, and again really nicely packaged. And you can see here this is a Node MCU-32 version 1.3, and really nice ESP32 dev board. ESP32s, most of them like this one, have Bluetooth and Wi-Fi on board, as well as onboard connections for USB via micro USB socket. Again, really nice board. So we need to put the basics of the kit together. And again, it's really simple actually. So what's great about this kit is if you're just starting out or not 100% familiar with everything, don't worry, it is really simple, these products, to get up and running very quickly. So the first thing we're going to do is we're going to put the ESP32 into its slots on the board itself. Now, it's marked with aerial, which is this piece here at the top. So ESP32 will go in like that. The OLED display fits into 4 pins neatly here, just on the top of the aerial. And I'm just going to turn that so I can see. And it's as simple as that. So that is now fitted. So the OLED display is in. Now for the sensors, this a little bit more tricky, but not, nothing major. So we need to make sure we get these up in the correct order. So temperature sensor is going to plug into the 4 wires here, and that is going to clip in to the I2C socket on the main board itself. And it's pretty self-explanatory really. The voltage, which is red, black, which is next to it, is always ground. And then you've got the 2 data lines, and I have got the correct way around for these. So green is SCL, and on the end yellow is SDA. And that's now wired in. It's as simple as that, and that connects into the I2C socket. Okay, so that sensor is now ready to go, and that just leaves our blood oxygen monitor sensor. And this is a more direct connection, to put it lightly. So basically we need to try and color code this, and by the way, the color code of this cable may vary in your kit from mine, but don't worry, as long as you've got the correct cables in the correct places, this will work absolutely fine. So I've got a purple and a brown on mine, which I'll use for my voltage and negative. So we should put purple, we shall say is VIN or voltage. We'll say the dark grey is ground, which on this one is on the other side of the board. And then again, you've got 2 serial lines. So we've got SDA and SCL. So we'll say blue for SDA and green SCL. Okay, so they're now firmly in. Now you're probably thinking, well, where do those go on this board? Again, don't panic. It's quite simple where they go. We're going to connect into the top GPIO pins here. And you can see here on the silk screen, they're actually labelled as SCL and SDA. So first thing to do is to put our voltage, which is purple, onto the red. We shall put ground onto black for ground. So that's the power for the sensor sorted. And it just leaves us with these two data lines. And I can tell you that green will need to go on the very top line. So green is SCL and blue SDA. Okay, there we go. So we've got both sensors wired up. We're more or less ready to go. Now what we need to do is we need to actually get some code up into our ESP32. To do that, we will connect to an external computer via the USB-A to USB micro cable. Like so. You can see we've got a red light on the board, so we know we're powered up. Of course, nothing will happen because it has no code loaded. Right, so this is the desktop of my Raspberry Pi 400, which is a all-in-one Linux ARM-based machine. You don't have to use the Raspberry Pi. You can use a Windows PC, a Mac, or even a Linux x86 desktop. That's totally fine. I'm just using this because it's a little more convenient for me for what we're trying to do today. So, first thing we can do is let's head over to Motoduino Lab, which is at motoduino.com, and you'll see there's two icons here for something called Motoblocky. Motoblocky is an online IDE that's best suited for Google Chrome. I'm running here in Google Chromium, which is kind of like an open source light version of Chrome. It works on this totally fine. And there's two buttons here, so we'll click this here for version 6, and this is going to open an on-screen online IDE, integrated development environment. Now we have to do a few setups. You might notice it's all in there. I believe this is Chinese. I might be corrected. It might be Taiwanese, but I think it's Chinese. Anyway, don't worry about the language because there's a button here and you can click English and it puts it into English. And then we need to select what it is we're actually using. From this drop-down menu, you can see there's all sorts of boards, including the Arduino, including the Nano that actually run with this. But we want to run with ESP32, which is the bottom option. And if you've ever used Scratch from MIT, it's exactly the same concept. So we actually build using blocks. So I have here advanced IO and I can open up a main program loop, which is setup and main loop. And then I can start pulling variables I need in, including the sensors and modules we need to use. So you might be thinking, oh, well, I don't understand how to program or code or read off these sensors. Well, luckily, it's really, really easy. So if I go to sensor modules here on this tab, and there is the first one, pulse and proximity sensor. And there's a setup, which I can pull into there. Might have had a little click then. And I can then read a value. So let's pull that. I'll just pull that off at the moment. And we can go read IR. So that's not connected to anything at the moment because I need to set up a variable. I'll do that in a moment. But first of all, let's have a look under displays and bottom one, which is our OLED. And you can see there's a picture of an OLED display and we can set up what we want. So we can set up, we can do an OLED setup like so. Let's just pull that block out of the way. And then we've actually got things like setting the cursor. We can set where the cursor starts, we can set rows, etc., etc. Now, I have spent a bit of time just off camera building something, and here it is. This is my interpretation of a complete program that will actually run on this device. So let me just go over what we've got happening. So I've set up a serial. You don't need to set up a serial for this, but I have set up a serial, and I've set the baud rate to 115200. There's the sensor being set up for the blood and blood oxygen sensor. We then set up the display. We need to rotate the display 180. We clear the display, we set where it is, and we're putting some text. And we can put any text we want. So I've just got ESP32 demo, but we could put anything we want in there if we want. Then we've got the main loop, and we're declaring 3 variables. So variables are here, by the way, and you can create a new variable you want. So we could say the sheep variable. If we want to create a sheep variable, and then we can pull sheep variable off if we wanted to use it, and then we can select what variable that's going to be. If we don't want a piece, by the way, we can click and drag into the bin, no problem there at all. So we've got heart, blood and temperature, and we're reading the 2 different sensors. So back under our sensors, we've got temperature sensors, and you can see here that this one here is the infrared temperature sensor, and that's the one included in the kit. So we can just drag this component off, and you can attach it to a variable, which I have done here, so we won't need to use that one particular. Let's look at this one. So we are looking at objects, that's a person rather than just the ambient air, and we can set it to Celsius or Fahrenheit, depending if you're metric or imperial. I am metric here, so we'll say Celsius. We can do a serial print to say that we're printing to OLED display. We could, if we wanted to, we could actually print the results to serial as well, but for the moment we're just going to print to the OLED screen. So we set the text, we create text with the word blood, and then we're going to put the value of blood, the variable, which is whatever the IR sensor reads, into here. We do the same again, and then we do the same again for heart down here. We print. Now there is a little bit I've added here, which is to delay. So we delay by about 1,000 milliseconds, that's 1 second, and then we clear the screen. Because otherwise, if you don't do that, the characters or the numbers on the screen will kind of just write over the top of each other into like a solid block. They don't clear the pixels that made up the previous number. So you need to clear the screen each loop and refresh all the text data. So that pretty much should work. Now, if you're running on Windows, you can download a tool here, which is the Motoduino broker.exe, and that will allow you to upload the code directly from the browser, only on Windows this is, to the actual ESP device. I'm running Linux, you can't do that on Linux, but don't worry, there's an alternative way around this. So if I click the tab here, ESP32, it will actually put it into C code, which is compatible with Arduino, and here is my entire code. So I haven't had to type any of this, and if you don't know Arduino C, don't panic. We can literally do the click together of blocks, and we can create our program, because it's quite a complex program. So we can click to save the sketch, and I need to call it something so I know what it is. So we'll call it Health Sense. Call it Health Sense. There we are. So we'll click OK, and that'll go into our downloads folder. So we can show that in folder, and there it is. So you see I've got a few previous codes, but here is the Arduino sketch as a .ino. So let's cut that out of there, and let's put that somewhere where we know what we're doing. Let's go in here, and I'm going to paste that there. So if I now double click this, it will open in the Arduino IDE. Now you will need to install the Arduino IDE. Again, it's really simple and really easy to do. It's free. You can just Google Arduino IDE and download it. And again, this will work for Mac, Windows and Linux. I'm running the Linux version for ARM here. This is 64-bit. Now it will say it wants to put it into a folder. We say yes, that's fine. Put it into a folder. And there is the sketch. Now that sketch would nearly be ready to go. But if you're brand new to using this, you do need to install a set of libraries and what we call a set of cores. Don't worry, it's really simple to do. All you need to do is first of all, back to the Motoduino in the browser, and there's a download here for download libraries for Motoduino hardwares. So we would want to download that library. So under Sketch, we would say include library, and then we'd select add zip file. You'd then go and find your zip file, which is under mine is under downloads. There it is, and I'd click to install that library, and that would work fine. That would then install the library. We do, however, still need the ESP32 core. Luckily, that's really simple to do. We go to File, Preferences, and Additional Board Manager here. This link here, which you need to copy and you need to paste into this file. If you may have other ones going on as well, you just need to make a new line and just install like so. You can say OK. Then we will go into Boards, Board Manager. This is under Tools. And in the search box, we'll do a search for ESP32. And the ESP32 library from Expressive Systems will show up. I've already got it installed, but you would click to select whichever version it is, which would be the latest version. You click Install, and it would install. That's all set up, and that will work. You may need to close and restart your Arduino IDE for it to read everything, but that should now work. And here is the Sense or Health Sense file that we created in Motoblocky. Now, bearing in mind that the ESP32 here on the board is plugged in to the Pi, it's lit up, so it should be connected and ready to go. And we need to select the board, and we would select Node 32S. Make sure we are on the correct port. If you're on Windows, these will be COM ports. Here on Linux, and I believe this does it on Mac as well, it's Dev TTY USB 0, so we're on the correct port. And we should be able to get board info. And you can see it is reading the board. So we should be able to do a straight upload. You could try and verify beforehand, but let's just do an upload. It will first try and compile. And if that goes through fine, it will then do a direct upload to the ESP32. And you see it's now uploading. And yeah, you can see we are now actually running. Now, the flicker you're seeing on the camera, I can assure you, is not there. It's just the refresh rate for the OLED is a little bit different to the camera in question. But you can see the board is now running. And the OLED has sprung into life. And we've already got a bit of data going on. So, it's picking up an ambient temperature at the moment, about 25.43 degrees. If I was to, let's say, put my finger just on top of the sensor, so that's jumped to 51, 49. I'm a bit warm then. It is warm in this room. There we are, 45. I hope you can just make that out on the screen. And if I release my finger, it'll go back down to measuring ambient temperature. So you can get direct, basically, body temperature or even ambient temperature straight off this little sensor. Now, the other, I'm not sure what it's reading at the moment. It may just be a false reading, but let's have a look at the infrared. So you see we've got a little LED here. And can you see now how, because I've got it facing up, the number for blood has dropped. So this should be blood oxygen level. And if I put my finger on that, yes, you can see straight away, 9.2, 9.1, it's up and down a little bit. But yeah, we're about 93,000 something. And the heart rate there is measuring, it's sitting at around 55.445, something like that. So there is a straight bit of data we're getting straight off the device. Again, I appreciate it's a little bit flickery for you on the screen. I can assure you that flicker is not being seen by me in person. Again, as I mentioned, it's just the refresh rates. So that works really well. I mean, that is the most simplest, basic setup. You could do a lot more with that, such as analysing the data. We could actually use the IoT features that we showed in the previous video. We could actually collate this data externally. We could connect via Wi-Fi, send the data off somewhere else. All sorts of things we could do. Now, I'm thinking this would be really useful if you were trying to prototype wearable health tech, you know, like sort of things like the watches and the bands and stuff that can measure all this. Well, this would be the prototyping base. You could actually develop your own tech using these building blocks before you in creating kind of health monitoring biotech, which you could either send that via Wi-Fi, or I guess you could actually set up a Bluetooth and you could log this locally. So a bit like how, you know, I'm trying to think of smartwatch devices that do that already. Well, you could actually build something that did that, but it could be your design or for another or similar kind of, I was going to say medical application. This can't be used officially in a medical capacity because it's clinically signed off, but it could be used in that kind of experimental capacity, especially for rapid prototyping of something like this. I mean, you just think trying to get hold of these kind of sensors and functions, even 10 years ago, would have cost a lot of money. But here it is for, you know, just under $50. And you can see it here on the techdesign.com page. Again, links are in the description. At the moment, time of recording, it's $48.62 per unit. Obviously prices fluctuate up and down a little bit, but basically at the moment we can safely say this is under $50 US, and you get a lot in this kit. As I've said before, what I really like about these kits is they actually give you the ESP32. I honestly thought with these that we were just going to get basically the dev board and a few extra sensors, and we'd have to supply our own ESP32. And I remember when I said to Tech Design originally, I didn't know it came with the dev board, so I said, oh, I've got one that might fit. You saw it in the previous video. Luckily with these they do fit because of the extended pins that allow for the different size ESP32s, not just the one included, to actually use this dev board, regardless of what it is you actually want to use the board for. But I have to say, I think this is a really interesting feature, and it definitely does work. And you see how simple I've set this up, and I'm not really into the whole health tech type thing, so there's an element of me not knowing what I'm doing, but I can get some stats recorded off this really simply, so it's a very elegant solution. So something a little bit different there, the blood oxygen and temperature monitor learning kit from Motoduino Lab, and brought to us today courtesy of techdesign.com IoT Marketplace. This kit gives a fantastic head start for anyone interested in developing healthcare, medical or even sports science based IoT tech, especially wearable tech. The Node MCU ESP32 microcontroller is a solid and proven platform thanks to its wide range of legacy support and easy integration with IDE spaces such as the Arduino IDE or the super brilliant and totally free Motoblocky Online IDE, together proving a very powerful development resource. As mentioned, all links are in the description to this video, so do go and check them out. I promise you, you won't be disappointed. If you want to see more product reviews from myself here on Wi-Fi Sheep, then do check out our review and unboxing playlist. And remember to like and subscribe if you haven't done so already. And I will see you real soon right here on the channel. Until next time, bye for now.